All right, there's a lot packed into problem 120 here from chapter 10. We need a balanced chemical equation. We need to figure out what methanol is, what the formula is. We've got oxygen gas at STP. We've got liquid methanol. We're going to end up with, well, at least needing to check to see if we have a limiting reactant here, because we have a quantity of methanol and a quantity of oxygen, and we need to know if we have the right ratio of reactants. We're then making carbon dioxide and water, and then we want to know the volume of the condensed water. So a very involved problem. So we've been given the mass of liquid methanol, we've been given the density of the methanol. We're going to use that to find grams, and then we're going to find moles of methanol. We know the volume of oxygen. It's 12.5 liters. We know it's at STP, so we don't need to use the ideal gas equation here to find moles, although we could use that. Although I don't think we know enough information, but we do know, since we're at STP, that 1 mole is 22.4 liters. And so that's a quick and easy conversion. So after you make your calculations using the volume and density of the liquid methanol, and then the molar mass of the methanol, you should find that you have 0.6632 moles of liquid methanol. You're then going to calculate the number of moles of oxygen, and you find that you have 0.558 moles of oxygen. You've got to look at those numbers and figure out if that's actually a 2 mole of methanol to 3 mole of oxygen ratio, and if it's not, which one you don't have enough of. These numbers make it pretty easy, because we're supposed to have more oxygen than methanol, and we have less oxygen than methanol, so therefore oxygen's the limiting reactant. Because of that, that's what controls the amount of oxygen, is what controls the amount of water vapor and carbon dioxide that get produced. So that 0.558 moles of water is going to react with methanol, and we'll have a 4:3 ratio of water to oxygen, so we've got to use that. We've got to do the stoichiometry here. All right, that's why we needed the balanced equation. So it's a 4 mole of water to 3 mole of oxygen ratio. We're then going to convert that to grams of water using the molar mass, and then we're going to use the density of water at STP to find the volume of liquid water. All right, we can't use a gas law here, because we want to know the volume of liquid water. We don't want to know the volume of water vapor. All right, so we've got to go from moles to grams, and then use the density of liquid water to find the volume that liquid water would occupy.